So now we can use our unit circle to solve trig equations. The way that that's done, in the past, if you were asked to solve sine of theta equals negative root 3 over 2, you would have found your reference angle by taking out your calculator and done sine inverse of positive 3 over 2. And once you had your reference angle, you would have said sine is negative in quadrant 3 and 4, so I can use my reference angle, 180 degrees plus my reference angle, to find my answer in quadrant 3, and 360 degrees minus my reference angle to find my angle in quadrant 4. But now that we've done our unit circle, we can now do some of these questions without our calculator. And we do it as follows. Is root 3 over 2 ever the y coordinate on your unit circle?
Yes.
Yes. What family is that in? 60 degrees or pi over 3. So right away, we know that our reference angle, and since this is in radians, we'll write all of our answers in radians. We know that our reference angle is pi over 3. Now, because sine is negative, when we go to solve our actual answers, we have to think, where's sine negative? Quadrant 3 and quadrant 4. What are the pi over 3 family members in quadrant 3 and quadrant 4? 4 pi over 3 and 5 pi over 3. And we're done the question. So you don't have to use your calculator to find your reference angle. You just recognize the value and state your reference angle from there. Question number 2. Is that too fast? We good? I can go back. Right, this is the pi over 3 answer in quadrant 3. This is the pi over 3 answer in quadrant 4. And it's those quadrants because we have a negative sign right there, and according to our cast rule, sine is negative in quadrant 3 and 4. Ready? Okay. So our next question. Cos of theta is negative 1. Again, when the domain is listed this way, 0 is less than theta is less than 2 pi, that's in radians, so our answer will be in radians. And 0 to 2 pi is 1 full revolution around the circle in the positive direction. So cos is your x-coordinate on your unit circle. Is your x-coordinate ever negative 1? Yes. When? Right? At pi. Done. That's all we have to do for this question. No reference angle needed. There's just one place on your unit circle where the x value is negative 1. So theta is pi. What about tan? Is tan ever equal to 1?
Yes.
What's your family that does that? 45 or pi over 4 family? Thank you. What quadrants will it be in? Quadrant 2 and quadrant 4. What's your pi over 4 family member in quadrant 2? 3 pi over 4. What's your pi over 4 family in quadrant 4? 7 pi over 4. And there's your 2 answers. So we can start to solve these trig equations really quickly now that we know our unit circle. Secant theta equals 2. Well, we don't have secant on our unit circle, so we need to write the reciprocal. What's the reciprocal of secant? But which function? Is it sine, cos, or tan? Cos. So if secant theta is 2, then cos of theta is 1 over 2. Is your x-coordinate ever 1 over 2? Yes. What's the family? Family 60 degrees in radians, that would be? Pi over 3. What quadrants are we going to look for the pi over 3 family? 1 and 4. So in 1, obviously it's going to stay pi over 3. What's the pi over 3 family member in quadrant 4? 5 pi over 3. Excellent. Sine theta plus 1 equals 0. Well, let's get the sine theta by itself. So we'd have to subtract the 1 and divide by 2. Are you okay with doing those two steps at the same time? Negative 1/2. Is 1/2 ever your y coordinate?
Yes.
Yes. So what's our family? What's our reference angle? Pi over 6. Which quadrants are we going to look in for our angle? Quadrant 3 and quadrant 4, because sine is negative. What's the pi over 6 in quadrant 3?
7 over 6 pi.
7 pi over 6. And in quadrant 4?
11 over 6 pi.
11 pi over 6. Nice. Next level. Okay. So the first level of questions were trig equations that used your solving skills from grade 9. Like the hardest one we ran into was like this one. Ooh, can we get sine by itself?
No.
Not very hard. Now, grade 11 type questions, we add quadratics into trigonometry. So now, if you're trying to remember, how did I do this? Well, just think about if I had x squared minus x equals 0, how would you solve that quadratic equation?
Get the x by one of the x by itself.
How do you do that? You need a hint?
Yes, please.
Rhymes with tractor. Factor, good. Yes. So here we have a common factor of x. You could factor that common factor out. It's equal to 0. So you would get, well, either this one's equal to 0 or this is equal to 0. So we have two answers, x equals 0 and x equals 1. So that was that skill of having a common factor and factoring it out. Now, we're not going to do it with x's, we're going to do it with cos and sine and tan. So in this case, what you're going to have is you're going to say, I have a cos in common. So I can factor a cos theta out, leaving me with cos theta minus 1. And then if I split it up where I'm multiplying, that means cos of theta is equal to 0 or cos of theta is equal to 1. And whereas you were done in grade 11 with your quadratic because you solved for x, we still have more work to do because we still need to solve for theta. So it becomes just like before, is 0 ever on your unit circle as an x coordinate?
Yes.
What angles? 90 degrees. And here it's, again, our domain is in radians, so so 3 pi over 2 and pi over 2. Is your x coordinate ever 1?
Yes.
When?
0, 360, and
0 and 360 degrees, but since we're dealing in radians, we would do 2 pi. Now, one of the things that you're going to get used to doing is solving equations from 0 to 2 pi. In fact, that's going to be your go-to. You're going to start solving and you're just going to solve from 0 to 2 pi. One thing I need you to always do is to check your domain, which is right here, at the end of every question. In this case, it does say between 0 and 2 pi. The other thing you're going to want to check is 0 included? Is there a line underneath this inequality? Yes. So I can keep this 0. Is 2 pi included? Yes. You will get some questions in your homework that look a lot like this, but it might be that they don't include one of those. So if the domain was written this way, you notice there's no equal sign underneath that second inequality, then 2 pi wouldn't be part of your answer.
if you had no equal sign and it's 0.
And if there was no equal sign on the 0, then none of those answers would be. So you always have to check your domain once you're done.
So when you're factoring out the cos of theta, why does that equal? Can you explain again why? I understand how the middle one equals 0, but why does the cos?
Why does the cos equal 0?
Yes.
Well, When you factor, what you're doing is factoring is you're changing an expression that's adding and subtracting. So initially our first expression here is adding and subtracting to an expression with two things multiplied by each other. And that multiplication is key because if I say I have two numbers and they multiply to equal 0, the only way that's possible is if one of the two numbers is equal to 0. Right? There's no other way you can take two numbers, multiply them, and get 0 without one of them being 0. And so when we factor, we say, well, either this one has to be 0, in which case we write cos theta equals 0, or the second one, cos theta minus 1, has to equal 0. And if this is equal to 0, cos of theta would have to equal 1, because then 1 minus 1 would be 0. Yes? So if you don't have equals 0 here, then your technique has no mathematical merit and you wouldn't get anywhere. So if this question had originally started here with a 1, you would have to first move that 1 over to the other side to make it equal 0 and then factor. So any kind of factoring that you do when it's not 0 on the other end won't help you. So that's why it only works if you make one side equal to 0. And that's true for solving any quadratic equation that you're going to use factoring. So here is another question with squared. How would you solve for y if you had y squared minus 3/4 equals 0? What would you do? Move the 3/4 to the overside and square root? So if you know how to do that with algebra that way, you know how to do it with trig functions. It's the same. So I'm going to use that strategy. I'm going to move the 3/4 over to the other side, and then I'm going to square root both sides. So when I square root both sides, what did I forget? Plus or minus, could be positive or negative. Anytime you take the square root of both sides, the answer could be the positive answer or the negative answer. If I simplify the 3/4, and here simplifying is important, it'll be square root of 3 over square root of 4, and the square root of 4 is 2. Why is that important?
That ratio is a number.
Yes, I know what you're trying to say. That number now, that's on our unit circle. What family does that belong to? And since we're dealing in radians, pi over 3. What quadrants will we look in for the pi over 3? All 4 quadrants. I call this one a family gathering because the whole family's there. So we've got pi over 3 in quadrant 1. We've got 2 pi over 3 in quadrant 2, 4 pi over 3 in quadrant 3, and 5 pi over 3 in quadrant 4. All 4 are there because it's plus or minus. Yes. So we had the square root of 3 over 4, right? And square root of 3 over square root is going to be square root of 3 over square root of 4. And the square root of 4 is just 2. So we do need to know our skills in simplifying because we wouldn't have recognized the square root of 3 over 4 until we've simplified it to see that it's the same as the square root of 3 over 2. Factoring skills continue. We have another quadratic equation. If you had something like 2x squared minus 3x plus 1 equals 0, how did you solve those questions? You'd factor. Now, you might have had some longer techniques for factoring from grade 11. Now that you're in grade 12, I want you to start forming a technique that you can go right from here to your answer. And in order to do that, we really have to think about what factoring is. Factoring is undoing multiplication. Okay? When you multiplied your answer here, so for example, the answer here is going to be 2x and x, 1 and 1, and they're both going to be negative. I'm going to tell you how I came up with that as a technique to do that directly, because I'm hoping you'll be able to do it that fast as well. The way that you're going to think about this is when you multiply this out, you might have learned this acronym to help you remember it, FOIL. Do you remember that? Seen that before? And that FOIL stands for multiply your first ones, multiply your outside ones, multiply your inside ones, and multiply your last ones. Now when you do that, a pattern emerges. A pattern emerges for all of your trinomials. Your first ones always end up being this first one. Your last ones always end up being your last number. And the outside and the inside always get combined to be that middle number. You might have noticed that while you've multiplied things out in the past. So when we go to factor something like this, and I just have this to start with, I'm going to say, for my first ones, how many possibilities do I have to get 2x squared? It has to be 2 and 1, right? That's the only way I can get 2x squared. So I'm going to write 2x and x because I know that that has to be it. There's no other whole numbers that work out nicely. There's fractions that would work, but when we're factoring, we're trying to find nice whole numbers. Then I look at my last one. How do I get 1? What times what is 1? The only whole numbers that work? 1 and 1. So in this question, I can figure out all the numbers without even having really to think very much at all. The last thing I have to do is figure out what the signs are. Are they both positive, both negative, one positive, one negative, which one? Well, this is where I look. What's my outside right now? It's 2x. What's my inside? X. How could I make that into a negative 3? I would need a negative 2x and a negative x to make that work. And we factored it. But one last thing that you'll always do when you factor is you're going to do a quick check. Are my first ones still 2x squared? Now that I've added my signs, are my last ones multiplied together to give me a positive 1? Yes. And does my outside and my inside combine to give me negative 3x? Yes. So now we're going to do the same thing when we have sine and cos. How do I get 2 sine squared? The only way is 2 sine theta and sine theta. How do I get 1? Has to be 1 and 1. And to get the negative 3, they're both negative. I quickly check it. Yes, everything works out. And now that we've factored it, we know here that sine of theta could equal positive 1/2. Here, sine of theta could equal 1. Is a half on our pie plate for our y values? What family? We're dealing in radians? Pi over 6. So then what quadrants am I going to look in? Quadrant 1 and quadrant 2. What's the pi over 6 in quadrant 2? 5 pi over 6. Is your y-coordinate ever 1?
Yes. On an axis.
What's the angle?
90, pi over 2.
Pi over 2, 90 degrees. Excellent. Yes. Oh, no. Okay. Perfect. So again, we factor. That allows us to solve. And again, it's really important that it was equal to 0. Because if factoring doesn't make sense unless it's equal to 0. And then we go from there. So let's add another level of difficulty. So we haven't used the word identity yet. Identity for trigonometry means something that is always true. And this was one of our big ideas. Sine squared plus cos squared is always equal to 1. So because that's always true, that's called a trigonometric identity. Now, in this question, if I had written it with x's and y's, this would have been negative 3y minus x squared minus 3 equals 0. And using your grade 11 math, you would not be able to solve that because you have one equation with two things that you don't know. The best you could do with that would be to graph it. And you'd say, oh, it's got an x squared, and I could graph it, and it would be a parabola. But you couldn't solve it. The questions you had when you had to solve these, do you remember questions like, do you remember questions like this?
Yes.
And if you had two equations, how could you solve this?
With the point in which they intersect.
It's the point where they intersect, but how did you algebraically solve this in grade 11? There was two techniques. Do you remember the techniques, what they were called? Substitution was one, and elimination was the other one. So the elimination technique said if you were able to get a variable that had the same coefficient but different signs, you see this one has 1y, this has minus 1y, you could add those equations together. And if I added those equations together, I would get 5x is equal to 1. Or 5, sorry. 2 plus 3 is 5. This plus this is 0. 2x. And you'd solve, oh, x is equal to 1. That was your elimination technique. Your other technique was called substitution. In the substitution technique, you took one of these equations, let's say this first equation, you moved the 2x over to the other side, and then you took this and substituted it in for the y in this equation. And that allowed you to solve. Now in grade 12, they're going to give you this question, and they're not going to give you the hint. I'm giving you the hint right now, because right now we have one equation with two things we don't know. So technically that's not enough to solve. Because if you have two things that you don't know, you need two equations. The second equation is in the hint. Since you know that sine squared plus cos squared is equal to 1, you can use that. And what we're going to do of those two techniques, we're going to use substitution. From here, can you see that you could get cos squared by itself by subtracting sine squared on both sides? And if you wanted to, you could get sine squared by itself by subtracting. Wow, that was fancy. And
You could tap anywhere. Drop the thing and tap
that didn't work. Clear all. No, I don't know if that was good. Collapse, expand, collapse, expand. Oh, there we go. In our situation, what do we have in our question? A sine squared or a cos squared? We have a cos squared. So we are going to substitute. We're going to rewrite equation 1. We're going to write negative 3 sine theta minus. Then we're going to put brackets in, and where the cos squared was, we're going to substitute in 1 minus sine squared. We still have the minus 3 equals 0. See how I use the substitution? What the substitution allowed me to do was change it so I have an equation with just one thing, just sine of theta. If I expand this, I'm going to get negative 3 sine theta minus 1. This minus sign gets distributed. So it'll become plus sine squared theta minus 3 equals 0. And grade 12 is a lot like this. We introduce something new, and you do your work. And while you're doing your work, it's going to trigger things you've learned in the past. What kind of equation is it now? It's a quadratic. How do we solve quadratic equations? We make one side equal to 0, and we either factor or solve it, right? So if I want to factor this, it would probably be easier if I wrote things sort of in the same way I'm used to factoring. The squared first. So sine squared minus 3 sine theta. The minus 1 and the minus 3 are like terms, so that I can put them together, get minus 4 equals 0. And again, I want you to go directly to factoring. How can I get sine squared? The only way is sine and sine, so that's easy. How can I get 4? Here we have some options. 4 and 1 or 2 and 2. Now, if you think about your outside and inside, using either 4 and 1 or 2 and 2, you need to get minus 3. What should you use, 4 and 1 or 2 and 2? 4 and 1. So we'll put 4 and 1. Now, figure out the signs. You need to get a negative 3, so we want our inside to be negative 4, our outside to be plus 1. That will give us negative 3. A quick check, are my first ones right? Yes. Now that my signs are there, are my last ones right? Yes. So when we split this, we get sine of theta equals 4, sine of theta equals negative 1. Now, this is a non-calculator question. When you have a non-calculator question, for solving it, that means you get to use your pie plate and know things from your pie plate. Is minus 1 on your pie plate as a y-coordinate? Yes. So, what angle does that? 3 pi over 2. Excellent. Is 4 on your pie plate? No. So how can we do this without, I'm telling you, you can do this without a calculator, but this isn't on your pie plate. How do you figure this out? So try it on your calculator. Try it on your calculator. See if it gives you a hint. What's the reference angle for sine theta equals 4? So you'd have to go sine inverse of 4. What does your calculator say? Did it yell back at you, Peter?
Yeah.
It yelled. What did it yell?
It said error, don't
Error. Why is this one not possible?
because it's undefined.
Yeah, why? How should you be able to know this without your calculator? How do I know that one's not possible? Well, there's other numbers that aren't on the chart that are possible. Well, this one's not 0 and it worked. But if I plug in 4 for this, 4 minus 4 makes that 0. So it's a possibility. But why is there no answer for sine theta equals 4? For this, you have to go back to your grade 9, grade 10 trigonometry. Okay? What does sine mean? Sine is opposite over hypotenuse. So if I make this a fraction and I draw a nice little right angle triangle with my theta, and I say my opposite's 4 and my hypotenuse is 1, what's wrong with that?
Because you can't have,
The hypotenuse can't be smaller than the opposite side. So anytime with sine and cos, where you get a fraction that's bigger than 1, that doesn't make sense, because you can't draw that right angle triangle with the opposite over hypotenuse being bigger than 1, because that would make your hypotenuse smaller than your opposite side. So this is something that they will expect you to recognize, or I will expect you to recognize, that if sine of theta is a number bigger than 1, you know that that's not possible. Now there's some hints. The fact that it's on a non-calculator part of your test, and it's not on your pie plate, usually that means it's not possible. So what do these questions look like if they're on your calculator part of your test? Well, here's our first calculator one. First of all, what kind of equation is this? Quadratic. So we need to make one side equal to 0. So earlier Jake had asked, well, what happens if it's not equal to 0? It's equal to 1. Well, we have to do the first step of bringing the 1 over. Now, when you go to factor this one directly, it's harder. It's harder because your first number is 6 sine squared, which already gives you 2 options, 3 and 2 or 6 and 1. So when I have those 2 options for that one, I don't start with that one. Life is, if I have to pick one of those 2, you could guess and check. It might take a little bit longer. But I go to my last one. Are there 2 possibilities for my last one? No, it has to be 1 and 1. So I start there. I start with the one that doesn't make me guess. It has to be 1 and 1. So you're looking, this usually works if either your first number or your last number is a prime number, because then there's only one option. Now that I know those have to be 1 and 1, when I go back to 6 and I think of 6 and 1 or 2 and 3, and I think of my outside and my inside, which one's going to work to give me 1? 6 and 1 or 2 and 3? 2 and 3. So then we can write 2 sine theta and 3 sine theta. The last thing we need to figure out are the signs. My inside is 3, my outside is 2. Do I want my inside to be positive or negative? Do I want my outside to be positive or negative? So that makes 3 minus 2. Yes, that gives me plus 1. So when we split this, on this side, are you okay if I do the 2 steps at once? If the first thing is equal to 0, I'd subtract 1, divide by 2, you'd get negative 1 over 2. Are you okay with that? If this one is equal to 0, I'd have to add 1 and divide by 3, so I would get 1/3. Are any of these values on our pie plate? The first one is 1/2. What's our family? What's our reference angle? Pi over 6. What quadrants are we going to look in? Quadrant 3 and 4, because sine is negative. So we're going to have 7 pi over 6 in quadrant 3, 11 pi over 6 in quadrant 4. Is 1 over 3? No, but it's less than 1. We could draw a triangle with the opposite side 1, hypotenuse 3. So here we have to go back to the same techniques that we used back in grade 11. In grade 11, you found your reference angle. How did you find your reference angle? You went to your calculator and you did sine inverse, and you used all positive values, even though these are positive values already. You did sine inverse of 1/3. Since our question's in radians, you would set your calculator in radians. And if you type it in your calculator, you get a reference angle of 0.34. Am I right?
Yeah, 0.34.
Excellent. Now, what quadrants is it going to be in?
1 and 2.
Quadrants 1 and 2, because sine is positive. So in quadrant 1, it will be the same as our reference angle. In quadrant 2, you would do, if it was degrees, you'd do 180 minus your reference angle. So pi minus our reference angle, 3.14, minus 0.34 will be 2.80. Okay, that's our first one with a calculator. And now I'm going to show you the nastiest ones that come up on the calculator section. So you don't have it on your sheet, I will make one up. Here is, what letter are we on? Are we on F? We're on G?
No, we're on F for failure.
F for failure? Okay, here we go. Solve for theta, and we will have sine squared theta minus 7 sine theta minus 1 equals 0. Boom. Why is this one harder than the last one?
Because it's not factorable.
It is not factorable. How do you solve things in grade 11 when you couldn't factor? Quadratic formula. Now, on your formula sheet, you have the quadratic formula. So because they gave you the quadratic formula in this form, they're allowed to ask questions that need the use of the quadratic formula. Well, in this equation, you have x's. What do we have here instead of x's? Sine. So when writing out the quadratic formula from here, instead of x equals, you will start with sine of theta equals negative b, so this will be negative 7 is plus 7, plus or minus negative 7 squared will be 49, minus 4 times 1 times a negative 1 be plus 4 over 2 times 1 over 2. And this means you have two possible answers for sine. Here's your first one. Sine of theta is 7 plus the square root of 53 over 2. And your second one, sine of theta equals 7 minus the square root of 53 over 2.
First one doesn't look like it.
So if we go to our calculator, this would be a great place to use our fraction button. Oops.
If it's greater than 1, which means that the fraction will yell the calculator.
Here we go. So if I go 7 plus, is it frozen on me? Oh no.
What happened?
My calculator froze.
Oh, mine doesn't do that.
All right, we'll shut it down and start it up again. Doesn't even want to shut down. Come on, calculator. There. All right, let's start it up again. Using the fraction button, 7 plus the square root of 53, all divided by 2. Push enter. This one is 7.14. Oops. And again, I'm teaching you some calculator tricks as you go along. The other one is 7 minus. You could retype everything. If you want to do things quicker, if you have the newest version of the calculator, you just hit the arrow button up till you highlight that. If you push enter, it retypes it, and then you can just go to the plus sign and change it to subtract.
You could also just press second, enter, and it'll do it.
Yes, you can also, if you have the older version of the calculator, if you just have a TI-83, you can't use the arrow keys to re-highlight something. But if you go second, enter, and you keep pushing second, enter over and over again, it will track back everything you've typed in the last, I don't know, 16 or 32 times.
It does on the new ones too.
It does, yeah, it works on the new ones as well. But here we get sine theta is negative 0.14. From here, this one you can do without your calculator.
Not possible.
This one's not possible.
Maybe because the hypotenuse is 1 and
Yeah, that one's bigger than 1, so you couldn't have that one as a triangle. That's not possible. Our second one is between 0 and 1, so we can do this one. But 0.14, if I recall, is not on our unit circle. I don't remember writing that one down. So we're going to need to find our reference angle. To find our reference angle, we do sine inverse of positive 0.14, right? That's how you find a reference angle. And when I made up this example, I made this one up early today to try it. The weirdest thing happens here. Check it out. So we go sine inverse. Now, if I don't want to retype all of this, I can go second answer, but can you see that that would have a negative in there? If I want to get rid of that negative, I could multiply by a negative 1, and that's like doing sine inverse of the positive value. Every time we find a reference angle, we're finding an actual answer. So if I do sine of theta is this, that means if I drew a triangle, if I made this a fraction over 1, that would mean that the hypotenuse is 1, and this opposite side is 0.14. And that would be my reference angle right there. Now, when we're figuring out a reference angle, we're figuring it out as if it was an angle in an actual triangle. You never measure the length of an actual triangle as negative. So you have only positive values for its lengths. So when you're figuring out that reference angle, you always use only positive values. Now the weirdest thing happens when you do sine inverse of that. It's almost exactly the same. So I randomly chose these numbers for this example, and they ended up being almost exactly the same, which I thought, that's the weirdest thing. Yeah, it's pretty cool. So our reference angle by pure coincidence is almost identical. There was a final exam 3 or 4 years ago where a number of students were given full marks that shouldn't have been, because a really common mistake when finding the reference angle is just to go sine of negative 0.014005. They just hit sine instead of, ooh, this one works. Oh, this is very close, right? Oh, this is a really good example. So what happened is the students wrote down this number, which is totally wrong, but the reference angle was really close. So teachers weren't noticing that they were making that mistake because the question was so close. Anyways, this is really cool that the reference angle happens to be really close to this. That is just pure coincidence.
I'm sure you just spent some time Googling.
Oh, you know, I just luckily chose those numbers. And then I also love the answer in this one, because this answer is going to be in quadrant 3 and 4. If you do pi plus your reference angle, you get 3.28. And if you do 2 pi minus your reference angle, you get 6.14, which also are very kind of cool numbers, because pi is 3.14 and 2 pi is 6.28. And these answers are 3.28 and 6.14, so I don't know.
Good playing around.
Having fun, noticing fun patterns in numbers makes me happy. So this is an exciting question for that reason. But the important part in this question is to see if you get a question that you can't factor, you're going to need to use the quadratic formula and then work on things the same way.